Many of our modern theories about how signals are received were developed at the Macy Conferences, a series of gatherings in New York that brought together intellectuals from a variety of disciplines. They ran the gamut from a mathematician who developed scenarios for nuclear warfare for the military to an anthropologist known for experimenting with LSD. Participants at the Macy Conference developed systems theory, cybernetics, cognitive science, and Gestalt psychology, and many other ways that we think about the mind, communication, and networks today. One of the attendees was Claude Shannon, an MIT-trained mathematician working at Bell Labs, who wrote the book The Mathematical Theory of Communication with Warren Weaver. Shannon drew a model of what he called a noisy channel, in which information would need to be decoded by a receiver at the other end. Shannon argued that the quantity of information transmitted is determined by the amount of uncertainty at issue in a given situation. For example, I might say that more information is conveyed by the next letter of the sequence CHO than by the next letter of the sequence CHOCOLAT. So that in my example, the components of the first message, CHO, could be a restaurant order for chocolate, but they could just as easily be forming the letters for chop suey or choice steak. In contrast, the completed contents of the second longer message, CHOCOLAT, appear easier to predict. Shannon's collaborator, Warren Weaver, went so far as to say information has, quote, nothing to do with meaning, although it does describe a pattern. This is because information refers not to a single message, but probabilistically to an entire set of possible messages. Weaver also claimed that the redundancy of written English affects how messages are conveyed through text. Quote, since English is about 50% redundant, it would be possible to save about 1/2 the time of ordinary telegraphy by a proper encoding process, provided one were going to transmit over a noiseless channel. When the noise on a channel, however, is there's some real advantage in not using a coding process that eliminates all the redundancy. For the remaining redundancy, helps combat the noise. Ordinary people have some sense of this redundancy in English, from which they infer that the use of acronyms in instant messaging does not significantly lower comprehensibility. One interesting case of how this colloquial understanding of theories of information functions is the Comabridge email that has been widely circulated in the past decade, which claims that people only need the first letter and the last letter of a word to decode a message.